Hello, ladies and gentlemen. Today we are going to be taking a look at congruent figures. So not just congruent segments or angles, but actually an entire shape that is congruent to another one. So our learning goals or our standards that we want to make sure that we accomplish today are that we can use the definition of congruence to show that two triangles are congruent by looking at their corresponding pairs of sides and angles. And also use congruence and similarity to solve problems. So in our case, we're going to focus on the congruent part of this and matching up corresponding sides and angles, but these two standards are the ones that we're working on here in this unit. So let's start with this really tough quiz, okay? So which one matches this? Which one would match this? Would it be A, B, or C? I'm hoping you said B, right? I'm hoping you said B. What about which one matches this? And I'm hoping you said A. Even though it's slightly turned, it's still the same triangle. And now 3, which one matches this? And again, I'm hoping you said A. The same shape, the same size, even though it's turned. So even at a young age, guys, we already focus on this idea, even as small children, of matching, of being equal or the same. I remember on Sesame Street having little snips or little clips about which one of these things is not like the other. Which one of these things is not the same? That idea, okay, that idea is something really young. We start working on that when we're really young. So the idea of congruent, guys, when two figures are congruent, we need to remember that their corresponding angles are congruent and their corresponding sides are congruent. So please make sure you write this part in your notes. When two figures are congruent, we need to look at the angles that would match up and the sides that would match up and make sure they are exactly the same length or size. So the angles and sides match up perfectly. The figure is the exact same shape and size. It may be turned, it may be rotated, it may be reflected or flipped over, but it's the same shape, just in a new spot, okay? So that idea of being congruent is one that we're going to start working on. So here's the first example I want you to just watch, not write this one in your notes, but we have here a congruence statement. Up at the top up here it says, given that figure ABCDE is congruent to figure FGHIJ. This is called a congruence statement. They're stating that the two figures are in fact congruent. And in this order of letters here, it just seems like it would be alphabetical, but really there's a reason they put them in that order. They're listed in that order because the first two letters here, segment AB, is congruent to segment FG. So we know this piece is congruent to this piece. The same thing with BC. BC are the second and third letters. BC would be congruent to GH, the second and third letters in the other figure statement. So if we continue all the way around, CD would be congruent to HI, CD congruent to HI, and also, last but not least in terms of segments, DE congruent to IJ. So we could put some little, maybe 4 little slashes on that one. Oop, we have one more I just see. And then maybe this one I'll put a squiggle, and this one I'll put a squiggle. Those two are congruent as well. So we've marked up our shape. All of these corresponding sides are congruent. We could conclude, we could make that list. We would say segment AB is congruent to segment FG, and so on. We could make the list of all of those segments. But not just the segments being congruent, also the angles, guys. Angle A was the first letter listed here. He corresponds or matches up with angle F. Angle F and A would get the same little slash marks through them. And angle B would be congruent to angle G. And angle C, 3 slashes, congruent to angle H. You get that idea. All the pieces, all the corresponding pieces, all the angles, all the segments would match up. So the importance of that congruent statement is really important. This is the first example I need you to write into your notes. So take a minute and pause the video so that you can copy the figures down and get all the measurements in there so that we can work on determining if they're congruent. Okay, so now that you've drawn the figures and you have them in your notes, let's see if they are in fact congruent to each other. When you want to determine if figures are congruent, you need to check to be sure all the segments, okay, all the lengths are the same as well as all the angles. So angle A up here is 80 degrees. It would match with angle E over here, who is also marked 80 degrees. So that pair of angles are congruent. The other 80 has a matching pair down here. And then the 100 has a matching angle over here. And then this 100 has a matching angle over here. So we've checked all the angles. Then we would need to be sure to check all the side lengths. AB has a side of 15, so does EF. AD has a side of 10, so does EH. HG is 15, so is DC. So when we've determined that these two figures do have all the same measurements, that is, they are marked the same in terms of length or congruent, then we can go ahead and say, yes, these two figures are congruent. So yes, they're congruent. The congruent statement now is us writing those letters that mark the vertices in the correct order. So let's say I go A to D to C to B. If I make my first one be A, D, C, B, then I have to say he's congruent to, I have to carefully choose the next pair, or the next letters actually on the other shape over here to match that same sort of outline. So I would need to start at an 80-degree angle like E, go to the next 80-degree angle like H, so I'll go E, H, G, then F around the shape. Being sure that all of those angles match in that order, okay? Now, did I have to start at angle A to list my first one? Nope. I could have started at D or C or B, but I just need to be careful to be sure that he has a matching partner on the other figure and that it does make sense that they are in fact the same number of degrees. Okay, so that's example one. Make sure that you wrote down that this is a congruency statement when you list all those letters like that and saying that they are congruent. The two figures are congruent. So here's another picture. Don't write this part down, but let's look at this one. Are they in fact congruent? In order to check that they're congruent, you need to double check all the measurements, make sure that they're all marked the same. Now be careful, they don't actually have numbers here, but I do see one with one congruent slash matching this one. I see three congruent slashes here. He matches this one. I see two congruent slashes here. Matches. This one matches this one matches this one, and so on. So I would say, yes, these figures are congruent, but I would say triangle EIG is congruent to triangle. If I do EIG, notice I started at the one with three slashes. I went along and I went down. I have to do the same thing on the next figure. So QOM. Okay, let's do another one like that. Here's another picture of some triangles. Are these triangles congruent to each other? I have three slashes here, here. I have one slash matching there. I have two slashes matching there. It looks pretty good. I don't have any markings on this side NL though. But both triangles share that side, so they would be congruent to itself if I were to separate those two triangles. So I can put three little slashes there on the one that they share because it will be congruent if I separated the triangles. So again, I would say yes, these two triangles are congruent. I would say triangle KLN maybe to start is congruent to triangle. Now if I started at K, went to L, then to N, the next one I would have to go M, N, L, based on the number of slashes that are in each angle mark, okay? Let's look at one more. Here's a picture of some triangles. Are these in fact congruent to each other? Remember, we're looking for congruency markings. Two here, three matches here, here, one matches here, here. Angle, yep. Another angle, yep. Would these angles that don't have any markings in here be congruent to each other? Yes, because they're vertical angles, so I'm just going to go ahead and add those marks. So again, yes, these triangles would be congruent. I'd say triangle DEF, or sorry, DEG is congruent to, then be careful how I start the next one, triangle H. Then I have to go to E, and then I have to go to F. Okay. So that's how we would list if shapes or figures are congruent. Be careful of the order of the letters. That's the important part there. So here's our second example that I need you to write into your notes. We're going to find the value of x here given that this triangle is congruent to this triangle. So we know these two triangles are meant to be congruent to each other even though they don't have all the markings on there that they might if we were trying to determine if they were congruent. We already know they are. So this says angle F, G, and H all have matching partners over here, R, S, and T. And then the side lengths for FG have matching partners over here. Okay, so if I were going to solve for x, notice my information about x is on angle R. If I look in this congruency statement, angle R is listed first. So is angle F in the other figure. So what I know is that angle R is equal in length, or measure in this case for angles, is equal to angle F. So this one and this one would have to be exactly the same in terms of degrees. So what I would need to do then is find out how many degrees are at angle F. It doesn't have any degrees listed there. But you know what? We have 55 degrees here, 65 degrees here. If we add those two together, that's 120 degrees, leaving me with 60 degrees up there for angle F. So then I can go ahead and say the 2x plus 30-degree angle in that other triangle matches up or has to be equal to the 60 degrees in the other triangle. So if I solve, I'd get 2x equals 30, x would be 15. So we're matching these corresponding angles now because we know we have similar congruent shapes. So last example to get into your notes, let's do one more like that where we're matching corresponding angles here. We're going to use the congruent statement to find the value of the variables here, not just x, but x and y. So we need to again examine who matches up with who based on this congruency statement. So angle F matches up with angle P. You can see they're both marked with two little red slashes there. So that means the negative 3x plus the y listed in that second triangle will have to equal 36 degrees. Now if we look at the other information about x and y, angle R here doesn't have any slashes, maybe 3 of them. He would match up with angle H here. Based on the congruency statement, we can see that's how they would match up. So if we knew the degrees of angle H, we could then have another fact about those triangles that we could write. So if I add up 36 plus 134, add those two up, that gives me 170 degrees. That means 10 degrees is left right there for that little skinny angle. So I know that my 2x plus 5y also has to equal 10. Now you've seen this before, guys. It's a system of equations where you have x's and y's joined together here. We can't just solve for x or just solve for y. We need to solve for both of them. So we need to eliminate something. Maybe perhaps you want to multiply this top one by negative 5. Why would I want to do that? Because I want to eliminate the y's, and right now the y down here has a positive 5, so if I were to multiply by negative 5, I would then essentially cancel out those y's when I go to add these two together. So let's multiply the top equation times negative 5. You'd have 15x minus 5y. Then you have to take negative 5 times 36, which would give me 180. Actually, that would be negative. And then you'd have 2x plus 5y equals 10. So that's negative 180 plus 10 would give me negative 170 when I add those two together. And then 15 and 2 is 17x. So we would go ahead then and divide by 17. X equals, that's right, you should be thinking it, 10, negative 10 actually. Okay, negative 10. So you might be thinking, oh no, we can't have a negative, but be careful. If you plug in negative 10 right here, we're still going to be okay because some of those coefficients were negative. We have to add some y's to this one. We're still going to be okay. But we only have x. We need to find y as well. Once we find the x, we're going to go ahead and plug them into one of these equations. I think I'll choose the bottom one here because that had no negative values for me to worry about here. So I'm going to take 2 times negative 10 plus 5y had to equal 10. So 2 times negative 10 is negative 20 plus 5y had to equal 10. So I'm going to add the 20. 5y equals 30. That means y equals 6. So I found the x and y using the system of equations now, but the whole idea is that I understand that these two figures are congruent, that they have equal measures. Okay, so I want to thank you for taking good notes today, and I'll see you later.